I want you to picture a gamer for a second.
Okay. I've got a mental image. Who are we looking at?
Well, but I don't want you to picture, the esports pro with the neon light headset.
Right.
And I definitely don't want you to picture the casual player on the subway just sort of swiping at Candy Crush.
So no hyper-competitive setups and no phone games. Who is this then?
I want you to picture an entity that plays No Man's Sky.
Oh, wow.
Yeah, or Teardown, maybe a little Goat Simulator 3.
Okay, that's a wild mix.
It is. It sits there, it stares at the screen, it uses a regular keyboard and mouse, and it's just desperately trying to figure out how to survive the night or, build a spaceship.
Right, playing the game just like anyone else.
Exactly. But here's the twist. This gamer isn't human. And it's not even a script running in the background code of the game like an NPC. It's actually looking at the raw pixels on the screen, just like you and I do, and figuring it out entirely on the fly.
It is a totally fascinating image, isn't it?
Yeah.
The whole idea of video games not just being entertainment or a way to blow off steam, but acting as a gymnasium. Like a high-fidelity training ground for the actual future of intelligence.
Exactly. And today, we are doing a deep dive into exactly who or what is training in that gym.
Let's do it.
We are looking at a brand new release from Google DeepMind, and it's called SIMA 2.
SIMA 2.
Yeah, which stands for Scalable, Instructable, Multi-World Agent.
And, that 2.2 at the end of the name is doing a whole lot of heavy lifting here.
Oh, totally.
Because this isn't just a patch update. It's not a new skin on an old system.
Right. Because if you remember SIMA 1, which came out roughly a year ago relative to the new paper, it was cool.
It was very cool.
It could follow instructions. It was a neat tech demo. But SIMA 2 feels like a massive level up.
It's a profound shift.
Yeah.
I mean, if SIMA 1 was about following orders, SIMA 2 is really about understanding the intent behind those orders.
Yeah.
DeepMind has essentially taken this gaming agent and given it a brain transplant. They've integrated their Gemini model right into the core of the system.
And that's the secret sauce, right? Gemini.
Yes.
We talk about large language models and vision language models all the time on here, but actually putting one inside a video game character,
It changes everything.
it really does. It changes it from a bot that just does what it's told into something that can actually reason.
Precisely. It transforms the agent from a pure tool into a companion. And the mission here isn't just to build a bot that can get a high score or, carry you to a win in Fortnite.
Right. They aren't trying to sell game boosters.
No, the goal is much, much bigger. We are talking about taking a really significant step toward artificial general intelligence.
AGI, the holy grail.
Exactly, AGI. And specifically, how that kind of general intelligence translates to robotics.
How so?
Well, think about it. If you can navigate a complex 3D world on a screen, handling the physics, using tools, dealing with lighting changes, completing objectives, if you can do all that, you are learning the fundamental building blocks of navigating the physical world.
Okay, so this is going to be a wild ride today. Let me just lay out the roadmap for everyone. Sounds good.
We're going to talk about how this thing plays games it has literally never seen before. We'll get into how it can actually talk to you while it's playing.
The dialogue stuff is incredible.
It is. And then, this part genuinely blew my mind. We're going to cover an experiment involving something called Genie 3.
Oh, man, the Genie 3 experiment?
It is straight out of the movie Inception.
That is the part that keeps me up at night, honestly. In a good way.
And of course, we cannot forget the most critical piece of all this, which is self-improvement, how it actually learns without us holding its hand at all.
The virtuous cycle.
So let's just unpack this step by step. Let's start with that brain transplant you mentioned. Yeah. You said SIMA 1 was an instruction follower. What does that actually look like compared to what we have now with SIMA 2?
So imagine SIMA 1 for a second. It was genuinely impressive for its time. It could handle basic commands across a bunch of diverse games. You could just tell it turn left or climb the ladder or open the map.
Okay, so very functional. Kind of like a remote-controlled car, but voice-activated instead of a joystick. In a sense, yeah. It operated visually. It used a virtual keyboard and mouse, but it didn't really understand the why.
The context.
Exactly. It was just mapping a command, literally a string of text, to a motor action. It sees pixels that look like a ladder. It hears the word climb, so it presses the W key.
Right.
But SIMA 2. SIMA 2 uses the Gemini model as its cognitive core. It doesn't just react to triggers. It thinks.
So if I were to tell SIMA 2 to, say, survive, it's not just scanning its database for a button labeled survive.
No, exactly. Because survive is a high-level goal. It's a totally abstract concept. To a standard computer program, the word survive is meaningless unless it already has a hard-coded concept of death and resource management.
Which it doesn't.
Right, so SIMA 2 has to reason. It thinks, okay, the user wants me to survive. To survive, I need to keep my health bar up. To do that, I need to find water. Or maybe I need to build a shelter because the sun is going down and it gets cold.
It breaks down the abstract idea into concrete, actionable steps.
Yes. It creates its own subtasks.
That is a massive difference. That's the difference between a macro script that just repeats actions and an actual teammate. It requires a working memory and a fundamental understanding of the game's logic, not just its controls.
And that leads perfectly to the dialogue aspect. Because it's powered by Gemini, which is natively a language model, it interacts with you. It operates in this loop called dialogue to action.
Dialogue to action.
Yeah. It can actually describe out loud what it intends to do. It can detail the steps it is currently taking for you.
Wait, so it's narrating its own gameplay like a Twitch streamer?
In a way, yes, but much more functional than just entertaining an audience. Imagine you're playing a co-op game with a friend.
Okay.
You don't just want your partner to run off completely silently without telling you what they're doing.
I hate when people do that.
Right. You want them to say, hey, I see a resource deposit over that ridge. I'm going to head over there to mine it so we have enough stone.
Right.
SIMA 2 can do exactly that.
Man, that feels less like a tool you are controlling and way more like a collaborator you are actively working with.
It really does. And to get it to that point, DeepMind actually trained it on a mixture of human demonstration videos that had language labels attached to them.
Okay, human gameplay.
But also, and this is the really fascinating part, they trained it on labels generated by Gemini itself.
Wait, pause right there.
Yeah.
So Gemini helped label the training data for the agent that is ultimately powered by Gemini.
Yes. It's recursion in the best possible way.
That is wild.
They use their strongest, largest vision language models to just watch hours and hours of gameplay footage and basically write down what was happening. That created a massive, rich data set to train the smaller, faster agent.
Wow.
The whole shift here is moving from command and control to collaboration and reasoning. It's no longer just go to that specific coordinate. It's let's figure out how to get over that mountain together.
That perfectly brings us to the next big point, which I think is the real test of intelligence.
Generalization?
Yeah. Because it's one thing to be good at a game you've played a million times. I can speedrun the first level of Super Mario Bros. With my eyes closed because I know exactly where every single Goomba is.
Muscle memory.
Exactly. But if you drop me into a brand new game I've never seen, I'm going to struggle for a bit while I figure out the rules.
And that easily where AI fails completely.
Yeah, they just break.
AI is notoriously brittle. You change the environment, you change the lighting a little bit, you tweak the physics slightly, and the whole system breaks down. It just panics. But SIMA 2 has demonstrated actual generalization.
Generalization. That really is the magic word in AI research right now.
It is. It effectively means this agent can function in games it was never trained on.
So they threw it into the deep end, just booted up a new game and said, good luck.
They did. They tested it on a new Viking survival game called ASKA, and they also tested it on MineDojo, which is a research implementation of Minecraft. SIMA 2 had never seen these specific environments during its training phase. It had certainly never seen the specific art style or UI of ASKA.
Did it just run into a wall over and over? Did it spin in circles looking for a familiar texture that wasn't there?
No, it succeeded.
That's crazy.
And not just by accidentally clicking the right things. This is where it gets really interesting. The source material for this deep dive highlights a very specific aha moment regarding something called concept transfer.
Oh, I loved this part in the notes. This is where the agent actually felt human to me.
Right. So SIMA 2 took a concept like mining, which it might have learned in one game. Say it learned mining in No Man's Sky, where you use a sci-fi laser to zap rocks.
Right.
It took that concept and applied it to harvesting in a completely different game where you might need to use a rudimentary axe or a pickaxe on a tree.
That sounds so simple to us, right? Because if I see a rock in a video game, I know I can probably hit it to break it and get stone. But for a computer, making that leap is incredibly hard, isn't it?
It is incredibly profound. It mimics actual human cognition. You don't need to relearn the fundamental concept of gathering resources every single time you switch to a new game.
You just look for the game's version of a rock and a hammer.
Exactly.
Yeah.
You understand the core principle. SIMA 2 is doing the exact same thing. It's not just matching pixels on a screen. It's transferring a semantic concept. It knows I need building materials. and it carries that understanding from one digital reality to a completely different one.
And it's not just reading text commands to figure this out either. I saw in the research that it's highly multimodal.
Yes, this is the Gemini effect coming into play again, because the underlying model inherently understands multiple types of input text, images. Video SIMA 2 isn't limited to a chat box.
Right.
It can actually understand sketches.
Sketches, like if I physically draw on the screen, because my drawing skills with the mouse are terrible. If I draw a wonky stick figure, is it really going to know what I mean?
It's surprisingly robust. You could draw a crude map or literally just circle a destination on the screen, and the agent understands that visual input as a direct command.
So if I see some weird alien tower in the distance and I don't know the name of it, I don't have to try to type, go to the tall, purple, spiky thing on the left. I just draw a circle around it.
Exactly. It interprets the visual gesture perfectly. It also interprets emojis.
So I can send it a tree emoji and an axe emoji, and it just knows, okay, time to go chop wood.
Precisely. And it works seamlessly across different languages, too. You aren't limited to giving it English instructions.
That's amazing.
This kind of flexibility is what really brings it closer to that true generalist label. It's building an internal model of the world, not just a static dictionary of text commands.
It seems like it's rapidly closing the gap with us humans, too. The performance stats in the paper are really impressive.
They were. On these difficult expanded evaluations, which are tests specifically designed to trip the AI up, SIMA 2 showed significantly higher task completion rates than SIMA 1.
Yay.
It is genuinely approaching human performance levels in these complex 3D environments.
Okay, so it's smart, it adapts to new games, and it can read my bad screen drawings.
Yes.
But this next section, this is where things got a little sci-fi for me when I was reading the brief. The inception moment.
The ultimate test.
Yeah. DeepMind decided to introduce SIMA 2 to another model called Genie 3. Now, for the listeners who don't know, remind us what Genie 3 actually does, because it's a whole other rabbit hole.
Genie 3 is what we call a world model.
Okay.
Think of it as a dream generator. You give it a single static image or even just a text prompt, and it generates a brand new real-time 3D simulated world.
Out of nothing.
Out of nothing. And it generates it frame by frame. It predicts what the next frame should look like based on whatever actions you are taking.
So Genie basically creates the matrix, and SIMA lives inside it.
That is a very apt analogy. Genie 3 imagines a world that quite literally did not exist seconds prior. And DeepMind dropped SIMA 2 right into the middle of it.
This is the part that gets me. SIMA 2 is navigating a world that is being actively dreamt up by another AI in real time. It's a hallucination that happens to be consistent enough to actually be played like a game.
Yes. And the result of the experiment was that SIMA 2 could sensibly orient itself in this dream. It understood instructions given to it. It took meaningful, logical actions.
Despite never seeing this world before, because no one had ever seen this world, it literally just got made up on the spot.
Exactly. This proves an unprecedented level of adaptability. If an agent can navigate a hallucination, a consistently generated dream world, it is demonstrating a level of robust reasoning that goes so far beyond just memorizing a map.
It's like having an AI test pilot flying a plane that is actively being built while it's already up in the air.
And flying it successfully.
Yeah.
But, there is a very practical reason for doing this, beyond just showing off incredible tech.
Right, because we run into a data bottleneck with humans eventually, don't we?
Exactly. Data starvation. To train a physical robot or a complex agent, you need millions and millions of hours of data. But human beings are slow.
Speak for yourself.
Well, we sleep. We have jobs. We can't just play Minecraft 24/7 to teach an AI. I mean, my nephew certainly tries his best, but he can't keep up with the scale needed for this kind of machine learning.
So humans are the bottleneck in AI advancement right now.
That is the fundamental limitation of supervised learning. You cannot always rely on human-generated data. It is expensive to gather, and it is finite.
So how does SIMA 2 get around that bottleneck?
Self-improvement. This is what we call the virtuous cycle.
Honestly, this sounds like the opening scene of every single robot uprising movie, but walk us through it technically. How does it actually teach itself?
It starts off gently. The agent begins by learning from those human demonstrations we mentioned earlier. It watches us play to understand the absolute basics of movement and game goals. But then it transitions to self-directed play, pure trial and error.
It just goes off and plays the game by itself.
Yes, but it's not just random button mashing. It's not the infinite monkey at a typewriter scenario. There is a structured loop. Gemini, which acts as the brain here, provides a task and an estimated reward for completing it.
Give me an example.
It essentially says to itself, I bet if you do X action, it will result in a good outcome. I bet if you combine this wood and this stone in the crafting menu, you will make a useful tool.
Oh, so it actually formulates a hypothesis.
Exactly.
Yeah.
SIMA 2 tries it out. The result of that attempt, whether it successfully crafts the tool or totally fails, is added to a bank of self-generated experience.
Like a memory bank of its own digital adventures.
Correct. And here's the really crucial key to all this. The agent uses this bank of experience to train the next version of itself.
So version 1 plays a game, learns some new stuff through trial and error, and uses that data to teach version 2.
Effectively, yes. It allows the agent to improve on tasks it previously failed at entirely independently. There is zero human intervention required at this stage.
Wow.
And they even saw this self-improvement succeed in those weird generated Genie 3 environments we talked about.
So it creates its own curriculum, it finds things it's bad at, practices them, and gets better all on its own.
It absolutely paves the way for open-ended learners, AI that just grows and adapts on its own. It solves the data bottleneck because it generates its own highly relevant data.
That is incredibly powerful and also, slightly intimidating.
Understandably.
But let's try to bring this back to reality for a second. Let's play devil's advocate. Why should I, the listener, care that a server at Google is getting really, really good at Goat Simulator 3?
It is a totally fair question.
Yeah.
Why does this matter at all beyond the video gaming industry?
Yeah, because I don't need an AI to play games for me. I play games to relax after work. I don't need a bot to beat the boss level for me.
The game is just the medium here. It's a low-risk environment. The underlying skills it's learning are universal. Think about what you actually do in a game like No Man's Sky.
Okay.
You navigate completely unknown terrain. You identify useful resources visually. You use tools to extract them. You collaborate with others to execute a complex task.
Okay, when you put it exactly that way, that sounds a whole lot like a job.
It sounds exactly like robotics. These are the fundamental cognitive building blocks for physical embodied intelligence.
It's embodied intelligence.
Right. If you want a robot to tidy your physical kitchen, it needs to be able to navigate the room without bumping into things. It needs to identify objects. Which one is the dirty plate? Which one is the trash can? And it needs to execute a multi-step plan. SIMA 2 is learning those exact cognitive skills in a safe digital sandbox before we ever try to put that brain into a heavy metal body.
Right, because if it crashes a virtual car in Teardown, it's totally fine. The pixels just reset.
Exactly.
But if it crashes a real car or drops my grandmother's fine china in the kitchen, not so much.
We need the mind of the robot to be fully trained and tested before we give it the body. And video games offer the perfect physics-based simulations to do that training at a massive scale.
Okay, I get it now. But we should also be realistic here. We've been hyping this technology up for the last 10 minutes, but this is still technically a research preview. It's not perfect yet.
No, far from it. It has real limits.
Yeah, let's talk about those limitations. What is SIMA 2 actually bad at right now?
Well, it really struggles with very long horizon tasks.
Like what? Telling it to beat the entire game.
Basically.
Yeah.
Or anything that requires extensive multi-step reasoning over a long period of time. If you drop it in Minecraft and tell it build a castle, it might gather some stone and lay the foundation, but then it's going to get distracted. Or just forget the architectural plan halfway through the build. It operates on a fairly limited context window.
Ah, so it has a really short attention span.
In a way, yes. And also, pure speed is an issue right now. It works with that limited context window specifically to keep the interactions fast. Low latency is absolutely crucial for gaming.
Nobody wants lag.
Right. But even then, running a massive model like Gemini to process every single frame takes serious computation. It's not going to be Twitch reacting like a pro gamer in Call of Duty anytime soon.
Makes sense. Nobody wants a laggy teammate pulling them down. What else?
There is the issue of finesse. Executing precise, low-level mouse and keyboard actions is still really hard for it.
Really?
Yeah. It can easily click a button to mine a rock, but can it gently rotate a lockpick in Skyrim using an analog stick? Can it perform a complex button combo in a fighting game? Not really. The micro movements are tough.
And what about visuals? I know computer vision has come a long way.
It has, but robust visual understanding of really complex 3D scenes is still an open challenge for the entire field of AI. SIMA 2 might clearly see a tree, but deeply understanding the complex geometry of a dense forest in a way that allows for perfect, fluid movement without getting stuck on a random polygon, that is still very tough.
So it's not going to be winning any major esports championships tomorrow.
Not yet. And DeepMind is being very clear about this. They emphasize that this is a limited research preview. They're only releasing it to a small cohort of academics and game developers right now to better understand the risks.
Responsible development, which
Yeah.
is always important when you're building things that can teach themselves. You want to make sure it doesn't learn the wrong things in that feedback loop.
Absolutely. You want solid guardrails in place.
Mm.
You don't want it maximizing a score function in a totally weird way that breaks the game physics or ruins the experience for the human players in the server.
So let's quickly recap all of this. We started with SIMA 1, which was kind of like a really well-trained dog. It was good at following direct commands, but very limited in actual understanding.
A good analogy.
And we've moved to SIMA 2, which is powered by the Gemini model, making it much more like a smart reasoning companion that can actually talk and see what you see.
It creates a true bridge between language and action. That is the key takeaway.
It can play games it's literally never seen. It can transfer concepts like mining to harvesting, and it can even navigate dream worlds generated on the fly by other AIs.
And crucially, as we discussed, it can improve itself without us holding its hand. It has a self-sustaining learning loop.
It's a huge validation of a new path in AI development. Instead of building one specific bot for chess and a totally different bot for Mario, we're building a generalist. One agent to rule them all.
Or at least one foundational agent that can unify all these specialized systems. It is all about versatility now.
So here's where I want to leave you today. We talked earlier about that concept transfer. Moving the idea of mining in one game to harvesting in another game, that's a massive digital leap.
It is a very significant one.
But think about this. If SIMA 2 can bridge that cognitive gap between two totally different digital realities, how close are we really to the ultimate transfer? The one from the computer screen to the living room?
That is the billion-dollar question for robotics.
If an agent can easily transfer the abstract concept of tidying a virtual room in a simulator to cleaning your actual physical kitchen in the real world, the line between the video game and reality starts to get very blurry.
It does. And when that line finally blurs, playing video games stops being just a distraction. It starts being the primary education platform for the autonomous workforce of the future. The game literally becomes the simulator for real life.
Definitely something to think about the next time you log on to play. Thanks for listening to this deep dive into SIMA 2. We'll catch you on the next one.